In our first film on radioactivity, we went through some of the basic terminology and looked at atomic structure. Right at the end of the film, we mentioned isotopes, and that is a good place to start this film. Atoms in any given element have a set number of protons, which is equal to the number of electrons. The positive charge of the protons cancels out the negative charge of the electrons. However, the number of neutrons in the nucleus can vary. Let's take carbon as an example. Carbon has a proton number of 6. It's the 6th element in the periodic table, and the nucleus of each carbon atom is surrounded by 6 electrons. These orbit the nucleus in an electron cloud in 2 layers. The inner shell with 2 electrons, and the outer shell with 4 electrons.
But not all carbon atoms are the same. We have carbon-12. The 12 is the nucleon number, the total number of protons and neutrons in the nucleus. As we know, the proton number is 6, so we can calculate that the number of neutrons is 6. 12 minus 6 equals 6.
But what about carbon-13 and carbon-14? These are isotopes of carbon. In fact, carbon-13, carbon-14 and carbon-12 are all isotopes of carbon. In the case of carbon-13, we have a nucleon number of 13, so the number of neutrons is 7. 13 minus 6 protons. In carbon-14, the number of neutrons is 8. 14 minus 6.
Isotopes of a given element have the same chemical properties, but different physical properties. The most obvious physical property is mass. The nucleon number is also equal to the relative atomic mass, so isotopes will have a different relative atomic mass, even for the same element.
But there is also another important feature. Whilst about 400 different isotopes are stable, there is a number of unstable ones. These are the ones that disintegrate and produce radioactive emissions.
We refer to these isotopes by their elemental name and their nucleon number. But before we go any further, there is an important name change when it comes to radioactivity. The nucleon number and proton number are borrowed from the world of chemistry. When dealing with radioactivity, we call the nucleon number the A number and the atomic number the Z number.
So let's start looking at some of these radioactive isotopes. We have already mentioned carbon. Carbon-12 and carbon-13 are stable, but carbon-14 is radioactive.
Potassium-39 is stable, but potassium-40 is unstable and produces emissions. And uranium-234, uranium-235 and uranium-238 are all unstable.
Other important radioisotopes include iodine-128 and radon-222. But for now it's not important to distinguish between stable and unstable isotopes and what this means.
In our next film we will look at nuclear fission, where the addition of a neutron will lead to instability and a chain reaction, which can produce a vast amount of thermal energy.
This is Science Rocks.